In the beginning, the solar system is a swirl of gas and dust. Little by little, it clumps together, smaller chunks of material plunging into larger aggregations. They form the planets. A giant star is dying. It explodes as a supernova, the shockwave blasting through space toward a cloud of hydrogen. The cloud collapses, forming rings of gas and dust. At the core, a nuclear furnace fires up. Our sun is born. So too, the 9 planets of the solar system. This empire of the sun is like a bubble. It's called the heliosphere. Within, the sun reigns supreme. So what is the sun, this local star of ours? Deep inside, at 27 million degrees Fahrenheit, it's a nuclear reactor turning hydrogen into helium. Each second, the sun loses 4 million tons of mass, matter that's unleashed as energy. Slice open the sun, and we see the path of that energy. From the white-hot core, it takes 1 million years to reach the surface. It takes just 8.5 minutes for that same energy to speed the 93 million miles to planet Earth, energy we call sunlight. By analyzing its spectrum, especially the pattern of dark bands, astronomers discover the composition of the sun. It's 73% hydrogen, 24% helium, plus a sprinkling of heavier elements. This is the solar surface, the yellow photosphere, temperature about 10,000 degrees, and above it, the fireworks of the red chromosphere. We look down on the photosphere, gas boiling up to the surface, cooler gas descending, each bubble the size of Texas. Not a sunflower, but a sunspot. Such blemishes periodically pock the sun. They're cooler than the surrounding photosphere. This one could swallow Earth. A group of sunspots. They can grow in 10 days, fade in 2 weeks. Here, the rotating sun has a spotty face. At other times, it's spotless. Sunspots indicate magnetic activity. They show where force lines burst from the sun and where they re-enter. The sun is like a garden sprinkler, swirling vast magnetic loops. Every 11 years, the magnetic poles flip. Midway between flips, the sun is at magnetic maximum. Its force lines generated by gases just beneath the surface. The surface spins at different speeds. At the equator, it rotates once in 26 days. At the poles, it takes 37. This tangles and distorts the magnetic field. The result is a seething ocean of energy, our star unmasked. Within the chromosphere, the inner atmosphere of the sun, arcs of gas sweep around magnetic force lines. Prominences leap into space, forming arches 30,000 miles high. eruptions spew from the granulated surface. Prominences are surges of flaming gas triggered by magnetic releases deep below. These are major prominences, jets licking up to 60,000 miles. Tiny Earth is set in to scale. But flares are more violent. They eject with the energy of 10 million hydrogen bombs. A flare blasts ripples across the solar face. The outer atmosphere of the Sun, the corona, is visible at a total eclipse when the Moon obscures the solar disk. The corona is hot, nearly 4 million degrees, and it dances a magnetic jig. Convulsions on the solar surface shape the activity above. From the Sun, that searing pivot of the solar system, it's an average 36 million miles to Mercury. Outwardly, Mercury is like our Moon, rocky, cratered, barren. But inside, like Earth, is an iron-rich core. That core is as big as the Moon, and at 70% iron, Mercury is the densest planet of all. Mercury is battle-scarred, scorched and irradiated by the nearby Sun, an ancient landscape of craters, cracks, and basins. This is one side of Caloris, the site of an impact that gouged a multi-ringed basin 800 miles wide. The culprit is a planetesimal, a lump of primordial matter. Such missiles rained in torrents upon the early planets. Mercury is riven with cracks, many of them the result of the Caloris impact. It may also have caused this lava plain, molten rock surging from beneath. But most plains post-date Caloris. They formed as cracks spewed great seas of lava. In contrast, Mercury's highlands have much sharper features. The epoch that created these plains runs for 1 billion years, but for the last 3 billion, there's been no volcanic activity. Mercury is inert, the interior solid. All that disrupts the surface are random whacks from space, calling cards like these. The arrow shows how slowly Mercury spins on its axis. It turns only 1.5 times in a single orbit of the Sun. The result is a crazy calendar. It means Mercury's day is twice as long as its year. The day lasts 176 Earth days, the year just 88. It gets stranger. If you stood on Mercury, you'd see the Sun apparently shrinking in the sky. It's to do with the variable distance of the Sun.